joke again. All right, this is actually the third time of trying this, but here we go. The mic is on now. For the third time, you will be learning this in just 13 months for those of you who went here last year. And third time, for what? Learning fractions. Or if you might think in a little bit different cadence, third down for what? Third down. Third time for what? Third time for what? Learning fractions. Now, some of you are still struggling with this. But here's the deal. It's not the fractions part of it that you're struggling with. It's actually the integer rules part of it that you're struggling with. And that you have notes for. Just to give you a precursor, or a preview of what's going to happen over the next 2 weeks, you have a quiz on Friday covering fractions, solving equations with fractions. On Tuesday of next week, you have an exam covering solving equations using decimals, fractions, and integers. That's Tuesday, a week from tomorrow. A week from tomorrow. So let's get down with this. Now, today we're going to be going a little bit faster because, as I said, you've had this 3 times. Okay? We've had this 3 times, so I'm going to zip through these. We're going to be smithing a lot of these because once you have a concept in and we do a demonstration, I expect you to be able to use the list of information of what you're supposed to do to apply to your homework tonight. You still only have just 20 questions on your homework tonight, but it does take up 2 sides, but not because there's a whole bunch of questions, but because I want you to have room to work. Here we go. Fractions, operations, review. Addition. I'm just going to read this. Follow along as I read. You can either follow along on the paper in front of you. You can follow along on your screen at home, or you can follow along on the screen in my classroom. Yes. Yes, as yes. Addition. Things to remember. First, what you're going to want to do is you're going to check to see if the fractions have common denominators. In addition and subtraction, put your knees under your desk, people. Put your knees under your desk. You're not turning around. Yes, you. Thank you. Stop. You have to have common denominators before moving on. You're going to add the whole numbers together. You're going to add the fractions together. Denominator stays the same. And if the fraction in your answer is improper, simplify it by changing it into a mixed number. So for number 1, we don't have any whole numbers, so we don't need to add those together as it's said above it. We have 5/9 plus 7/9. We already have common denominators. We already have common denominators, so we can just go from there. We just have to add 5 plus 7 and keep the denominator the same way that it is, which is going to be 12/9, which is going to be 12/9. Now, that's an improper fraction, and we aren't going to be improper. We're going to be very proper in here. So we have to be doing, there's one of 2 ways of doing this. You can do the recognition that is going to be a 1 whole number there, and that's going to be 3 left behind, which simplifies to 1 1/3. Or what you can do is you can do it the other way, which would be first in, second out, 1, 9, 3, then it's 1 3/9. Number 2. This one does not have common denominators. We're dealing with a negative number and then a positive number. Mr. Webb?
Where are you getting that?
Getting what?
I'm on the wrong side.
Yes, I have the hole punch on the wrong side for several of them. Please be sure that you have the side that says addition and the name on the top. For this one here, we have to find a common denominator. Now, when you find the least common denominator, you are also going to be finding the least common multiple of the 2. You could always do the multiplication of the 2, but that just takes longer to reduce. This is a situation where we have two prime numbers that don't share anything until their common multiple. So it's 11 times 3, which is 33. So I'm going to multiply this by 3, multiply this by 3 as well, because I have to keep an equivalent fractions. That's also from last month. This one's going to be multiplied by 11. This one's going to be multiplied by 11. So I have negative 12 over 33 plus negative 22 over 33. Now I'm going to use the integer rules for adding integers with different signs. So I'm going to do this in a different color because this is something that you wouldn't have to write on your paper because I assume that you know how to do this. 22 minus 12 is equal to 10. So this is going to equal out to be 10 over 33. Now I know that it's going to be a positive 10 because when I did that difference of those two integers, 22 has a higher absolute value than 12. So I know that my numerator is going to be positive. And I'll just now be thinking, okay, I'm done with that one. Can I reduce? No, I cannot, because the only factors of 10 are 2 and 5 and 1 and 10, and there are none of those go into 33. So I'm done. And next, the first thing that we're going to have to do with this one is we're going to make it into an improper fraction. Okay, it was belching at the table. We need to make it say, hey, you're improper. So we need to make it improper. Yes? 3 times 3 plus 1. So we have 10 thirds plus a negative 15, 16, 17 thirds. We already have common denominators, so we can just go from that point. And using my integer rules, I would do 17 minus 10. And what's that answer?
That'd be I just have a question.
Okay, sure.
How come, like, when it's negative, wait, I don't know how to prove this.
Why am I subtracting 17 or 10 by 17?
No.
Okay.
Like, say you have negative 11, and you need to get it to 33. So, like, in this, you multiply by 3, but when you multiply by 4?
Okay, you lost me. Can you repeat that, please?
So, say you have negative 11.
Okay, say I have negative 11.
And you need to get to 33.
I need to get to 33.
We say that you multiply by 3, but when you multiply by 4, it's... Oh.
If you did...
Yeah, because... Yeah. I know what he means, but that's not what he does.
Are you looking at number 2 by chance?
No, I was just wondering because it was on something I did.
Okay. So now I have to do, with my integer rules, 17 minus 10, which is going to be 7. And the reason I did that, I know that it's going to be a negative 10 because of my integer rules where 17 is a higher absolute value than 10. 7 over 3. I'm going to erase that because that would have been some scrap paper work. And I have to go negative 6. No, it's negative 2 and 1/3. Negative 2 and 1/3 is the correct answer. Do you agree? Fantastic. Oh, why not? Okay. Okay. Student disagreed because she just wanted to disagree. Now with this one here, the reason that we put these in there is because I want you to rewrite this side by side so you can see exactly where the denominators are and how they relate. So you can see where the denominators are and how they relate. Okay? How the denominators are and how they relate. What is that? Sorry. Little rats. Oop, there it is. The quiz, now? That one is, that's next one. Tell you what, no, tomorrow. We're going to write this side by side. You with me? Sorry, I stepped away for a moment. We're going to write these side by side. So I'm going to do, well, as I write them side by side, I'm just going to go ahead and take care of making them improper right off the bat. So I have 7 times 5 is 35 plus 1 is 36, negative 36 over 5, plus a negative 6 over 7. I need to find a common denominator with 5 and 7. And I think of my multiples of 7. Okay, 7, 14, 21, 28, 35. Darn, none of those share a common multiple until 35. So what I had to do with this one is I had to multiply this by 5. So I'm going to multiply this by 5. I'm going to multiply this by 7. I'm going to multiply that by 7. So 6 times 5 is 30. 25 times 7 is 35. 36 times 7 is going to be on a scratch piece of paper. (21 plus 4 is 25). So now I have negative 252 plus third, yes. 8017. 8 and 1/7. Okay, we're going to do it step by step because not everybody is getting the wrong answer like you just did that quick. So, boom. Yeah, watch. I'll show you how he got it wrong. So we have 252 negative plus 30. So that comes out to be a negative 200 and we are adding, oh, that's a negative, 282 35ths. There you go. So glad you found your mistake. Now, what's that? I am adding because we have a negative number being added to a negative number, which means that we are going to become more negative. So if we're negative, we're adding more negatives. That means we're going to be more negative. Okay?
I want to be positive.
So I have to do, stop talking. On a scratch piece of paper, I'm going to do 35 divided by, 282 divided by 35. That doesn't go in that many times. If I wanted to do 35 times 10, I would have 350. 350 is actually 70 more than 280. So I'm really close. So I can do 7, which is 280. That leaves a remainder of 2. So now I have a negative 7 and 2 35ths. Can I reduce that at all? No, I cannot. So that's my final answer. Negative 7 and 2 35ths. So this isn't new. This is just kind of, this is actually a straight up review, and that's why I'm shooting through this. Have you had the fractions in the past? No? Okay, I can. This has all the information in like weeks of stuff from 6th grade, and I can help you with it, okay? Now we have improper, unlike denominators. What's that? What was that?
I was getting from the pen.
Is that your pen? Why was your pen on his desk?
She gave it from my pen.
Why did you give him your pen? His pen?
Because he kept on throwing it at me.
Okay, well, let's put the pen away because we're not checking any work today, so we don't even need a pen. I have 9/10 plus 13 halves. 9/10 plus 13 halves. I'm going to make this one change on the right side because a least common multiple of those two is just 10. The left side doesn't even need to change. So I have 9/10. I'm going to multiply this by, that's multiplication, times 5 plus 65/10. That would be 74/10. And that's obviously just 7 2/5. That's all positives? Nope, sure don't. Do 74.
Reduction.
Yep, reduction, bro. And that's an ugly 7, so I'm going to redo that 7. There we go. That's not even any better. Whatever.
You need to use line.
Yeah, exactly. When you're writing that big, when this is 7 inches, this would be a foot about. Okay. Number 6, back to it. You guys just, every time I turn around, you're turning around, which means I want you to move right here. Every opportunity you have, you're turning around. Whether it's your fault or not, I don't know. But you can resist from turning around even if she is talking to you. But she was the one that was caught. It was you. I'm going to make this an improper fraction. 6 times 12 is 72, plus 72 plus 5 is 77. This number is huge. Now, in order to do that, I'm going to rethink whether I want to make this an improper fraction or not. Okay? So what I'm going to do is I'm going to add the whole numbers first. I'm going to go, and erase that. I'm going to do the whole numbers first. I'm going to do 10 plus 12, which is 22. So I have 22 plus 3/4 plus 5/6. I pulled out the whole numbers. If you think about it, 10 and 3/4 is the same thing as 10 plus 3/4. Yes, Chloe, you may. Yep. You will be able to do this. And that's what we did a little bit on the one before it. So now we just have to find a common denominator between 4 and 6. And what would that be, Miss Boyette? 12. So I have 22. That's going to be still tagging along. And in order to get 12, I have to do this times 6. No, I have to do that times 3. I'm going to do this times 3. To get 6 to be 12, I had to multiply that by 2. So now I have 9 and 12 plus 10 and 12. So now we're going to have 22. It's a bad accent, whatever that was. 22 and 19/12, which equals 23 and 7/12. That's a bad 7 again. I can't write 7s today. Here we go. 23 and 7/12. Finally, we're a quarter done with our notes. All right. Next one. Yes, sir. $23 and 7/12. 23 and 7/12. Next one, subtraction. Things to remember. Here's the bottom line. It's the same as addition. You need to have common denominators. The difference that we're going to do with this one is an integer rule where we are going to keep, change. Yes, ma'am?
You can dot your I's and cross your T's. Oh, Mr. Smith!
Actually, it's because I deleted everything from the previous time I did this, and it looks like those two got taken along. But we're not even there yet, so what do you think of this?
I don't like it.
Yeah, now we're gonna have to do it. Great.
Sorry.
I'm just kidding. Now, as it says there, subtract whole numbers in the fractions. Make sure your fraction is reduced. Here we go. We have the same denominator, so we don't have to change anything. We have the same sign, and the second fraction is smaller than the first, so we don't have to go into any negatives. So this one is just 9 minus 7, which is going to be 2/11.
That's my favorite date.
Yeah?
It is?
Yeah, in Europe, where they say the month first.
Oh.
This one here, now we have a number that in the numerator that's bigger, so it's possible that we're going to have to deal with some negative numbers. This is a situation with the integers where we keep, change. So I'm going to keep this negative 2/3 as being negative 2/3, but I'm going to change the second fraction to being this. 2/3 plus a negative 4/7. And that's the integer rules where if you add a negative, it's the same thing as subtracting. So now I have to find out a common or least common multiple of 3 and 7. And they're both prime numbers, which means what do you have to do? Actually, I've heard this from you. Yes.
What do you want? Oh, times them by each other.
You're going to multiply them by each other, yes. So I'm going to multiply them. This one's going to be multiplied by 7. 3 times 7. This is going to be 7 times 3. 4 times 3. This is going to come out to be negative 14 over 21. Plus negative 12. My goodness, there's so many sickness noises happening in the classrooms today. Now I have a negative 14 plus another negative. If I'm already starting at negatives and someone's adding more negatives to me, I'm going to become, yes? Okay, what more negative, which is what?
26.
Negative 26 21sts, which simplifies out to be negative 1 and 5 21sts. Good. Exactly. You can't reduce because they don't have common multiplers or common factors. Good. Now, I promised my fifth period that I'd record this period so I could do what I did during fifth period. So we have a situation here where we have two double negatives. And I'm going to rewrite that. I'm going to keep it as an improper fraction just because it's subtraction. I want you guys all doing that so we don't make any silly mistakes. So I do 9 times 9, which is 81, plus 8. So I have 89 ninths. Now I have two negatives. So whenever I have two negatives, I want you to think of your super cool, not dorky, not unhip at all stuff, math teacher that you had when you were in 7th grade. Because when you have a double negative, it's negative, negative makes a positive. And then you think of the... We will add them. Oh, boom, that's cool. That's the coolest thing you're going to see all day. What's that? Yeah, that's right, a 32-year-old being hip and awesome with 13-year-olds and 12-year-olds, and then doing an awesome happy dance. Sorry, but don't show any of your friends because I don't want to blow up on YouTube and nothing, being like, oh, you should have seen this St. Louis area teacher. It was pretty cool. Is that the what? Never mind. All right. Continuing on. It's going to be something that gives your attention to this rather than takes it away from it. So we're going to continue with this. Remember, I'm not waiting. I'm keeping going. So remember, it is negative, negative. You will add them, okay? Minus a negative. It's a double negative. You're going to add them. So I have 15 plus 2, which is 17 thirds. Good. But it wasn't recorded. I didn't record much in 6th grade, and I still don't. So now I have 89 minus 17. Oh, nope. I have to make this into common denominators. So this can be multiplied by 3. This can be multiplied by 3. So I have negative 89 ninths. Yes, because in order to get 3 to become 9, you have to multiply it by 3. And to keep it an equivalent fraction, you have to multiply the denominator, numerator by the same thing. So I have 9, and that's 51. And now, because of my integer rules, I do 89 minus 51. So I have negative 38 ninths. And the reason why it's a negative is because this this absolute value is bigger than this absolute value. And the what's that? Stop tapping your pencil. And this wouldn't need to be on the homework because I expect you to know how to do that. So we have negative 38 ninths. And that comes out to be... Can I reduce that at all?
No, you can't.
You are correct. They don't have any common factors, so I cannot reduce it. Sister, you are way ahead of me. Yeah, we're not even halfway through the notes. Negative 4 and 2 ninths. Yes, sir. Andrew. Yes. Math. Ew. Yeah, that's my middle name. Yep. Ew. Now I'm going to make a correction to the typo there. Haha, wonderful. There we go. Fix that. Now I have a situation where no, I'm not going to do that. So I'm going to make this an improper fraction. 7 times 5 is 35. Plus 7, or plus 2 is 37. 37 fifths plus negative 3 fifths. Yay. I have common denominators. I love when that happens. So that's just going to be 34 fifths, which comes out to be 6 and 4 fifths.
Which cannot be reduced.
It cannot be reduced. You are correct, sir. And this one, it does not have a pretty, common denominator with multiplications when we do make it improper fractions. Yes.
For the last one, isn't it
Plus negative 3/5, yeah.
Well, we did negative.
Plus negative 3/5.
Why is it negative?
Yeah, because
It's a minus.
subtraction and negative.
We talked about that, yeah. Because if you had $5, I remove $3 from you. You have $2 left, right?
Yeah.
Okay. Now, if you had $5 and I add a negative $3 from you, how much do you have?
We got $2.
Yeah. So either way, the same thing as if you subtract one number from the other is if you add a negative. Okay. Because plus is opposite of negative, or plus is opposite of minus. Do you agree? Okay, and a positive integer, the opposite of that positive integer is just putting a negative sign in there. And we've gone over that before.
Father made the soul of space. Sorry.
Focus. Focus. Next one. Number 5. We are going to make a big bad improper fraction with this. Because I don't have a common denominator, but I want to make one, and I want to make sure we don't make any silly mistakes. So with this one, I have 5 times 13, which is going to be 65 plus 4, which is 69, negative 69 fifths, minus 42 plus 5. So it's plus a negative 42 plus 5 is going to be 47 sixths. Because I want to show you how knowing the distributive property makes stuff pretty simple to do. So I have 69 fifths. I need to multiply these to get a common denominator. Okay, and since the shortest one that happened is actually when I multiply them together. Whoops. This is actually when I multiply them together. So what I'm going to do is I have to multiply this times 6, this times 6, this times 6, this times 6. And because I'm familiar with the distributive property that we've done in the past, you're right, 5. Thank you for catching that. Yes, this should be 5. Good catch, Chloe. So with this one, 69 times 6, because of the distributive property, I'm just going to do 6 times 70, which is 420, minus 6. So I have negative 414 over 30 plus a negative 47 times 5. That one is going to be 47 times 5 is going to be like 250 minus 15. Because what I did there was I did 50 times 5 minus 5 times 3. That's how I did the distributive property of that. Now I just have to do, I have negative 414 plus negative 235, which is going to be negative 649. Yep, over 30.
That can be reduced.
That can be reduced by a bunch, right?
By 200.
What?
Just kidding.
Yeah. No.
So what I'm going to do is I'm going to do first in, second out. This goes in twice, 60. This goes in once, 30. So I have 21 and 19 thirtieths, and I cannot simplify that. Halfway through the notes, yay. And 19 thirtieths. And I'm going to erase this because this is something that I would imagine you to put on a separate sheet of paper, like a notes. Yep, another piece of paper. I would expect you to know how to do that. I'm not going to draw. Go back to this guy. And we are going to Smith number 6. And for those of you that are at home and or you don't, if you care at all, Smith is when we've already gone over a concept and we don't need to just keep doing a million examples if we've already done one like it. Million is a bit of an exaggeration. All right. Multiplication. Yes, sir. No, because once I don't think that doing it again would be more beneficial than giving you time. Please stop talking, Cole. Thank you. It would be more beneficial than moving along, because you've all had this, but I guarantee you there will be only so many of you that will not get any wrong in the homework tonight. Things to remember. Number 1, check to see if the problem includes mixed numbers. If it does, change the mixed numbers into improper fractions. Change any whole number into fractions by putting them over 1. Cancel if possible. I'm going to have you go. Cancel if possible. That will significantly reduce. Can you please put your foot down, sir? Thank you. We are going to be, it is significantly going to reduce the amount of time spent reducing later. It also makes your multiplication smaller. So, and then, of course, simplify when you're done. So we have negative 5 6 times 7 ninths. Whenever we have a negative times a positive, it is going to be a negative number. Whenever we have a negative times a negative, it is going to be a positive number. Whenever we have a positive times a positive, of course, it's going to be positive, and that's a review from the multiplying integers notes. So we have negative 5 times positive 7, which is going to be just negative 35. Negative 5 times a positive 7.
Negative times negative is
Yep, you are correct. Then we have 6 times 9, which is going to be 54. And that one does not share any common factors, because the factors of 35 are, let's see, 5 and just 7. Yeah, 1, 5, 7, and 35. So that one's done. This one here, we can reduce right off the baseball bat. Yes? 4 and 2. I'm going to reduce this. I can divide this by 2. I can divide this by 2. So I'm going to rewrite those like this. So I have 14 divided by 2 is 7. I have 2 divided by 2, which is 5. Then I have 9 and 3 can be reduced. This is a cross reduction. Divided by 3. Divided by 3. So 9 divided by 3 is 3. 3 divided by 3 is 3. So now I have a negative 3 multiplied by a negative 1, because I go right across the top, and I just have like that. 3 divided by 3 is 1. You're correct. Thank you. And 7 multiplied by 1 is just dropping on the floor, 7. And that is a positive number, because a negative times a negative is a positive. And as you can see on the right side of my board here, as I was explaining to my accelerated group on Thursday, all 3 of these are equivalent fractions. Negative a over b, negative a over b, and a over negative b, as you can see to your left there. That one's just 3/7. Finalmente, número 3, we have 3 1/3. I need to make this an improper fraction. This is going to be 10/3. Times 6 over 1. As it says in your instructions, you have to make whole numbers over 1. Because 6 divided by 1 is 6. I can reduce this as well. This divided by 3. This divided by 3. The other one can't reduce, so I just have 10 over 1 multiplied by 2 over 1, which comes out to be 20 over 1, which is just simply 20. And you are going to be smithing numbers 6, 5, and 4. We're going to smith 6, 5, and 4. Number 1 for division. The first thing to remember, check to see if your problem includes mixed numbers. If it does, I'm going to stop reading right there. You know why?
Why?
Because there's only one thing you to remember about this, other than the
Change flip. That's the action. Everybody's going to know how
we're dividing fractions. That's right. Keep charge flip, I guess. Change.
I like to charge you.
Keep change flip. Yeah, that's the action. So It's keep, change, flip, and then we just multiply the same way that we did multiplying fractions. And because it's just like multiplication, we're only going to do one example. I want you to smith everything but number 2, and we're going to do number 2 together. Yes, sir. Schneider, you have a question?
Oh, I just noticed that keep, change, flip, if you rearrange it, it's KFC.
KFC. I like it. And I like KFC. So, hi. Thank you. Thanks. Here we go. We are going to keep, change, flip these two fractions. So I have keep, which is going to be, I'm just going to do it up here. We have a little bit more room, I think. Keep, which is 9/14. Change that into multiplication and flip these guys over. Okay? So now I have 27 over 28. 27/28, and that's my final answer. Yeah, it's just like multiplication, except the keep, change, flip. Goodbye.